We also need to look at this other rule of differentiation here. Ordinarily, we derive term by term. So the example in the previous lesson was just one term. But what if we have 2 or 3 or 4 or 7 different terms? And the rule of differentiation is you differentiate each term individually. So the derivative of f of x is f dash x, g of x, g dash x, etc. So you just derive each term with the rule we previously learnt. So I've got several examples here. You can write those down, and then on the next slide we're going to solve them. Okay, so here's the first 4. So the first one, you'll see we've got 2 terms, so we differentiate them separately. So our rule says the indice is swung to the front. Now there's a coefficient of 1 there, which 2 times 1 is just 2. So it's 2, we rewrite the x down and we reduce the index by 1. So 2x to the 1, we don't really need that 1, plus, swing the 3 to the front. If there's a constant there, we times by it, write down the x and reduce the coefficient, reduce the index by 2. Next one, 2 terms again, 5x squared. So 2 is multiplied by 5. So we get 10, write the x down and reduce the index by 1. And again, we don't actually need that one. I could rewrite that as 2x plus 3x squared. That will suffice for the future. Minus, and then if we look at the next one, 5 times 2 is also 10, x to the 4th. Now the next one, we don't have any rules at the moment for deriving a fraction, and this is a simple fraction. So if it's something like this, we need to rewrite it with a negative index. So actually what we're looking at is finding the derivative of 2x to the minus 1. And then it looks like what we're used to. So the derivative of that is negative 2, minus 1 times 2 is negative 2, x to the minus 2, and really we should get rid of the negative indice again, back to a fraction. So that's minus 2 over x squared. Just remember, the minus 2 is only being applied to the x, so that's why that ends up on the bottom. And the minus 2 out the front here is simply your constant. And the last one, well again we've got a fraction. We don't have any rules at the moment for a fraction. And this is a simple fraction. So if we can simplify it, we do so. So what I'm going to write is d dx, and I'm going to divide everything in the top by x. So I've got 3x plus 5x to the 6th. Just going to rub that out and make that an x. Okay. And then our same rules apply now. This is 3x to the 1. So 1 times 3 is 3x. If I reduce the 1 by 1, I get a 0. So we'll fix that up in a minute. Over here we've got 30x to the 5th. That's a straightforward one. Now, as you know, anything raised to the power of 0 is, that's right, 1. So that's 3 times 1, which is just 3, plus 30x to the 5th. And the general rule is if you've got a constant and just an x term, the derivative is simply the coefficient in the front of the x. Okay, and the final 3. Now the first one, a constant, a number. We don't have any rules for that. However, what if I rewrote it as, that's 8x to the 0, similar to the last one. That's correct, x to the 0 is 1, so that is equivalent in its expression. And if we apply our differentiation rules, 0 times 8 is 0, x to the minus 1. Well, it doesn't really matter what the index is. Anything times by 0 is 0. So there's another rule, is that the derivative of a constant a number with no x, really it's x to the 0, the derivative is 0. And the reason is given up there. Okay, the next one. Now, again, we don't have any rules for brackets. We will soon, but we don't have any rules. And it's easy enough to multiply this out. So you need to get single terms. So what we're looking at is the derivative of, and I'm just going to expand it out. So it's 6x squared. I've got minus 4x plus 9x, that's a plus 5x minus 6. And then I've got single terms, so it's 12x to the 1 plus 5 minus 0, and I don't need that. And the last one I wanted to do, just for you to remember that we're deriving in terms of x. It's the derivative with respect to x. 2 pi here is just a number. Pi is 3.14, etc. So that's just a number. That's as though there's a 6 there. So we treat it as though it's a coefficient in front of it. So 7x cubed, the derivative is 21x squared. Now, there's a 1 there, isn't there? Maybe I should write the 1 there. So it's 1 times 2 pi is just minus 2 pi x to the 0, which is 1. And then this last term here, I'm going to rewrite that as a minus 3x to the minus 2. And if I multiply those two numbers, I get a plus 6x to the minus 3, which needs to be written back as a fraction. Plus 6 on the top and an x cubed on the bottom.